Welcome back. We have been learning theory about firm. We have seen their legal organization. Now it is time that we get back to practicing some of the problems for which we have learned the concepts. So the first problem is that how to maximize total marks. And deliberately in the beginning I have kept examples with numbers, and later on again we will get into algebra and calculus. Here the question is that you are taking two courses this semester. One is economics and other is statistics. This is just an assumption. You have quizzes coming up in both classes. The following table shows your marks on each quiz for different number of hours studying for each quiz. For the purpose of this problem, let us assume that you cannot subdivide hours. So if you cannot say that I would give half hour to one subject and 2.5 hours to other subject. Maximum hours we have kept it at 3. So even if you don't study economics, you are going to get 7 out of 10, and if you don't study statistics, you will get 6 out of 10. But if you study 1 hour of economics, you will get 7.7 marks. So there is an increase from 7 to 7.7, and if you study statistics for 1 hour, you will get 6.8 marks. You have to be careful little bit, because you cannot study, let us say, 3 hours of economics and 3 hours of statistics, because total hours given to you is 3 hours. So of course there are two ways to solve the problem. One is, of course, you have 3 hours, so let us say 1 eco 2 stat, that's a possibility. Another possibility is 2 eco 1 stat. Third possibility is 3 eco 0 stat, and one more possibility we can use 0 eco and let us say 3 stat. So here economics is decreasing, in this way stat is increasing, and because total time is fixed. So how many marks you will get here? And this is a brute force technique, you don't need anything, but such problems are quite easy to handle and you can use this brute force technique. But the principles that we have learned help us understand these questions really well and help us solve this question real quickly. So 0E and 3S. So 0E is 7 and 3S is 7.8. So that gives you 14.8 marks. 1E and 2S. So 1E is here 7.7 you get, and 2S is 7.4. So you get 7, 7, 14, and here 15.2. And 2E 1S, so here you are for 2E, and 1S here you are. So one can write 8.2 plus 6.8, and that is 15 marks. And next combination is 3E 8.5 and 0 here, because 0S, so that gives you 6, 14.5. So of course you should pick this particular combination, which is 1 hour on economics and 2 hour on stats, and this is the best outcome that you are getting. But let us solve it slightly differently. Rather than using the brute force technique, let us use the marginal gain that one additional hour of studying makes for different subject. So here marginal gain is, let us say, from here once you move, so you are studying 1 hour of economics, the gain is here for 0.7 marks. The gain here is, if you study 2 hours of economics, this last hour that you spent, the gain is 0.5, and here the gain is 8.5 minus 8.2, that is 0.3. And of course from 0, This exactly same thing you do for the stat also. Here gain is 6.8 minus 6 and that is 0.8 hours. The gain here is 7.4 to 6.8, that is 0.6, and here you have 7.8 to 7.4 is 0.4 hour. Now in the earlier technique, if one had said no, you have now only 2 hours, you have to do the recalculation once again. But in looking at this table now, it's very simple. If you have 1 hour, where should you give? The maximum gain is here, that's what you are getting. Studying 1 hour of stat, the first hour gives you 0.8 marks extra, and that you are not getting anywhere. So first hour you should definitely give to stat. How about second hour? Should you devote the second hour on stat? If you have devoted the second hour on stat, you would receive 0.6 marks extra, but that is less than 0.7. So second hour should go to economics because there the addition is of 0.7 marks. So first hour to stat, second hour to, if you have, to eco, and if you have third hour, one additional hour, this is already gone, this is already gone, so again gain here is higher. So third hour should go to stat. And this is the way we are doing the marginal contribution. Once you have one additional hour, this is the way you should utilize it, and this covers all the possibilities. Let us look at slightly more complex problem. Now let us say you are zonal manager in railway and you have to decide how number of trains that you should run between city A and city B. Okay, let us say, and these are made up numbers, these are not realistic numbers, these are made up numbers. Let us say the daily cost to run a train is 15 lakhs, whether you run one train. Let us say that daily cost to run a train is 15 lakhs. If you run one train, it's 15 lakhs, two trains, it's 30 lakhs, three trains, it's 45 lakhs. The variation of the total benefit, because if you run more train, your benefit is going to higher. So you have, if you run 0 train, your total benefit is 0, your average benefit is also 0. If you run one train, then your total benefit is 30 lakhs, average is also 30 by 1, which is 30. If you run two trains, your gain is 48 lakhs, but average is now 42 by 2 is 24. Here it's 3 trains 60 lakhs, average is 20. Here 4 trains 64 lakhs, average is 16, and so on. I want you to pause for a moment and figure out that how many train would you run. Once you write down your answer, then we are going to solve it. Again, there are two different techniques. One is brute force technique and second the marginal analysis. But I want you to pause and think about it and write down your answer and see what happens. I hope you have written down your answer. So let us look at marginal benefit. From 0 to 1, the marginal benefit is 30. Okay. From 1 to 2, the marginal benefit is just 6. Sorry, 18. How are we calculating the marginal benefit? Let us look at it. How did we get this 30? 30 is because 30 from one train and 0 from 0 train. So it's 30 minus 0. This is 48 minus 30. So it is 18. Now we can do here, that is 12. Here we have just 4 and here we have just 2. And how much is the marginal cost? In each case you run one additional train. We have, sorry, it's a 15 lakh, so it is 15, always 15. So you should be running just 2 trains, because if you run third train, additional earning that you have is just 16 minus 48, that is of 12 lakh rupees, but running an additional train will cost you 15 lakh rupees. So your loss is more than the gain, and therefore you should not move from second train to third train, and you should run only 2 trains. You could have done using brute force also, but that takes longer. This marginal analysis helps. Now again we are getting back into the discussion of profit maximization, and we have already seen that firms are typically to make profit. There are of course firms which are not interested in making profit, but most firms are interested in making profit. Even if there is a section 8 company or for not profit organization, their job also should be that whatever they are doing, they should be doing efficiently, they should not be wasting. So it's the key word is optimization. As I already said in the beginning, in profits case it's maximization, in cost case it's minimization. You should maximize profit, you should minimize cost, and we are going to talk about all these things in detail, but today just a sneak peek that first we are seeing in this video. So profit is denoted by capital Pi, which is equal to total revenue minus total cost, and which is we can write in short TR minus TC. What we have TR is P multiplied by Q, where P is per unit cost and Q is the quantity sold, and total cost depends on Q. So how many units you should produce if you are interested in maximizing profit? So before we go to calculus, let us understand that as of now you are producing Q naught amount of output, and if you move from Q naught to Q naught plus 1, let us see what happens to total revenue. Total revenue changes, let us say from Q naught plus 1, total revenue changes to Q naught, and this we can call marginal revenue. That is the change in revenue to produce one more unit. Yes, I am using the rudimentary definition of marginal revenue. We could have better definition, but for basic intuition it helps to understand, it helps to take that rudimentary definition. And what happens to cost? Let us see that cost increases, let us say total cost increases in, this is also C, and this is basically marginal cost. So when we move from Q naught to Q naught plus 1, revenue increases by marginal revenue, but cost also increases by marginal cost. So if marginal revenue happens to be greater than marginal cost, then profit is increasing by producing one unit more, and therefore you should move from Q naught to Q naught plus 1. It's always a good idea. And if marginal revenue minus marginal cost is less than 0, it means by producing one more unit, whatever you are gaining is not good enough to cover the cost for one additional unit, then you should not move to not Q naught to Q naught plus 1. So this logic tells us that at optimal point, when you should, at how many units you should produce, what is optimal, the level that you would not like to change. So the criteria for optimality is that marginal revenue at that point, let us say at Q naught, if Q naught is the optimal point, because here we have taken that it's not optimal, it's not optimal, but if MR at Q naught happens to be equal to MC at Q naught, then you do not have incentive to increase production or decrease production, and so this is a criteria for optimality. One thing that you should understand, wherever MR Q naught is equal to MC Q naught, it doesn't mean that you are producing optimal amount of output. It's other way around. When you are producing optimal amount of output, at that point marginal revenue is equal to marginal cost. Now you can tell me, you can go back that at this point at level 2 production, marginal revenue is 18, marginal cost is 15, they are not equal. So why we are not proceeding further? Here assumption is that we have only discrete jumps. We are moving from 0 to 1, 1 to 2, 2 to 3, 3 to 4. 2.2 is not possible. But when we write in this way, here we are allowing for discrete jumps. So let us understand that what should be the criteria when only discrete jumps are allowed. So you should produce Q naught when M marginal revenue at Q naught is greater than marginal cost at Q naught and marginal revenue at Q naught plus 1 is less than marginal cost at Q naught plus 1. That would be the criteria there that we had used earlier. So if you write mathematically, it appears difficult, but otherwise it is very, very simple. So if you allow for continuous change, if at Q naught you have achieved optimality, then at that level marginal revenue is equal to marginal cost. What I want to emphasize that we have not assumed that how P is being determined, how Q is being produced. This is universally true. A firm that is interested in maximizing profit, at level of profit maximizing output, marginal revenue should be equal to marginal cost if you are allowed to vary quantity in continuous manner. Let us do one problem that a firm faces price P. So here we are assuming that a firm is operating in a market where it doesn't have any control over price. Perhaps it's happening, and we will see when does it happen. But for this sake of this example, we can assume that it happens when there are so many sellers and everyone is selling the same item, and so price 66 is fixed and no one can change independently. And let us say cost function is given as this particular entity. What is the most profitable level of output? So we have to obtain Q naught, that's the level this firm should be producing. So let us take a look at it. What is the requirement? That marginal revenue should be equal to marginal cost. We will assume that Q can be varied in continuous manner. So if total revenue is P multiplied by Q, and as Q goes up, P doesn't change, how much is the marginal revenue? We can calculate total revenue at Q plus 1 minus total revenue at Q, and this is PQ plus 1 minus PQ, so which is equal to exactly P, because PQ will get cancelled with this, we are left with P. So marginal revenue is P. How about marginal cost? How to obtain marginal cost? So of course there are two ways. One, we vary total cost by 1 unit, but here we are allowing the continuous change, and as you have already done calculus in your first year, you should be able to obtain marginal cost is nothing but the rate of change in total cost that we had talked about earlier with respect to Q, and so this is what we have to obtain. If you want to notice what we had studied earlier, P is the fixed cost and this component is the variable cost. Okay. So another thing you should understand, that when you are obtaining the marginal cost and we will come back to this particular point also once again, that when you are obtaining the marginal cost is also equal to that derivative of variable cost. Why? Because write down the total cost as fixed cost plus variable cost d by dq. As fc is fixed, it will give you 0, and then this is equal to dvcq by dq. So whether you differentiate the variable cost or you differentiate the total cost, you are going to get the marginal cost.